Speak about the ventilation. There is minute ventilation, there is alveolar ventilation, minute ventilation and alveolar ventilation. So minute ventilation equals what? Tidal volume multiplied by respiratory rate. Tidal volume multiplied by respiratory rate. So this is the total volume of gas entering into the lung per minute. So total volume of gas entering into the lung per minute. So it's a tidal volume multiplied by respiratory rate. This is the minute ventilation. What is meant by alveolar ventilation? This is the volume of gas from this total volume from this total volume reaches to the alveoli. So it's called what? Alveolar. So you must exclude what? The physiologic dead space. So the tidal volume minus the physiologic dead space, which equals anatomic dead space plus alveolar dead space multiplied by respiratory rate. So what is the difference between the minute ventilation and alveolar ventilation? Minute ventilation, the total volume. Alveolar ventilation, the volume that reached to the alveoli from this total volume. So you must exclude the physiologic dead space, which equals the anatomic dead space plus the alveolar dead space. So the normal values, respiratory rate between 12 to 20 breaths per minute. Then tidal volume 500 milli per breath. Then what? Then this is physiologic dead space. 150 milli per breath. 150 milli per breath. So the tidal volume minus the physiologic dead space, 500 minus 150, so it's 350. This is 350 multiplied by respiratory rate. This will equal alveolar ventilation. This will give you the alveolar ventilation. But if you calculated the minute ventilation, you will calculate 500 multiplied by the respiratory rate. This will give you the minute ventilation. So the difference between the minute ventilation, all total volume of gas that's entering to the lung. In the alveolar ventilation, only the volume of gas from this total that reached to the alveoli. So you must exclude the physiologic dead space, which equals the anatomic dead space plus alveolar dead space. Then the same you will multiply it by respiratory rate. Then here we have lung volume up to 5 liter. So during inspiration it will increase, during expiration it will decrease until reaching to the functional residual capacity. What is the functional residual capacity? It's a balance between chest wall expansion and tendency of the lung to collapse. The balance between chest wall expansion and tendency of the lung to collapse. Then what? Then alveolar pressure between 0, it will be negative, then it will be positive during expiration. So during inspiration it will be negative. Why? To create negative alveolar pressure, to make the air outside the lung more positive than the alveolar pressure. So the negativity of alveolar pressure will facilitate the inspiration, will facilitate entrance of air from outside into inside, because the outside is positivity more than the negativity of the alveolar pressure. So this will lead to inspiration and increase in the lung volume. Then during expiration there is what? There is positivity of alveolar pressure more than outside the lung, leading to expiration and decrease in the lung volume. Then the next one, intrapleural pressure is always negative. Lung volume will reach into 0.5, alveolar pressure may be negative during inspiration. It will be negative during inspiration and positive during expiration. But intrapleural pressure will be always negative. So negative 5 into the end of inspiration, negative 10. Then the end of expiration, it will be negative 5. So it's always negative. Why? The negativity of intrapleural pressure will make a balance between the movement of chest wall and lung. So if the intrapleural pressure pleura between the chest wall and the lung, if it's negative, so this will lead to a balance between the movement of both of them, chest wall and lung. So if the lung has the tendency to collapse, the chest wall has the tendency to expand. So the negativity of intrapleural pressure will make them a single unit in movement. So if there is movement of the chest wall, the lung will follow the chest wall. If there is movement of the lung, the chest wall will follow the lung, because of negativity in between both of them, negativity in intrapleural pressure. So negativity of intrapleural pressure will make chest wall move with the lung, and will make the lung move with chest wall, because there is negativity in intrapleural pressure between both of them, and it will return to the negative 5. Then here, this curve, this is the volume, and then there is transpulmonary static pressure. So this is what? This is the functional residual capacity. This is the balance between the tendency of chest wall to expand and tendency of the lung to collapse at this point. This is the normal curve. This is lung tendency to collapse, chest tendency to distend, expand. So this is net compliance, and this is the functional residual capacity. So restrictive disease begins with letter R. So any restrictive disease will make this curve going to the right. So restrictive to the right. So fibrosis is a restrictive disease going to the right. So obstructive will be the left, will be the opposite. So emphysema obstructive to the left. So any disease which will express restrictive pattern, it will go R, restrictive, R, right, to the right. So fibrosis here to the right, emphysema obstructive, the opposite to the restrictive. So it will move left, emphysema to the left. Then the next one, this is a curve called hysteresis. What is hysteresis? Hysteresis, the lung inflation follows a different pressure volume curve than lung deflation. So inflation and deflation, inspiration, expiration, due to need to overcome surface tension forces in inflation. What's meant by this? You have here the inspiration and you have here the expiration. So inflation, then deflation. You will notice that there is resistance at the beginning of inspiration. It will take time. There is difference in the curve between inspiration and expiration. So there is slowing down at the beginning of inspiration. Because of what? You want to overcome the surface tension in the alveoli to begin inspiration. So slowing down at the beginning of inspiratory curve, inspiration, because you want to overcome the surface tension to open the alveoli for inspiration. So the inspiration will take another curve rather than the expiration because of this period. What is this period? This is slowing down at the beginning of inspiration, because you want to overcome the initial surface tension to open the alveoli to begin the inspiration. So it will take time to begin the inspiration. Then there is deflation, there is expiration. Then the next one, we have the lung and chest wall, because of historical reasons. Small pressures, pulmonary pressures will follow what? Centimeter of water. So here the alveolar pressure centimeter of water, then intrapleural pressure centimeter of water. So this is expression due to historical reasons. Then elastic recoil, tendency of the lung to collapse inward, and chest wall tendency to what? Is bring outward. Distension of the chest wall and tendency of collapse by the lung. So at functional residual capacity at this point, there is a balance between the lung and chest. So airway and alveolar pressure equal atmospheric, what's inside the lung will equal what's outside the lung. It's called 0, 0, 0, and intrapleural pressure will be negative. We say that intrapleural pressure is always negative because you want just the chest wall to move with the lung and lung to move with chest wall. So there must be negativity between them to make them single unit in movement. Then preventing atelectasis. Means what? Atelectasis, collapse of the lung. Why? Because if there is negativity between chest wall and the lung is collapsing to in expiration, this negativity between the chest wall and the lung will prevent the collapse of the lung. So the inward pull of the lung balanced by outward pull of the chest wall. Then system pressure is atmospheric at this point. Functional residual capacity balance between chest wall and the lung. Then what? Then pulmonary vascular resistance is at minimum at this point. Functional residual capacity, the pulmonary vascular resistance is at minimum. Then compliance means what? Tendency of chest wall to expand. So change in the lung volume for a change in pressure. So change in volume pair it divided by a change in pressure. It's increasing by surfactant. Why? Because surfactant against the surface tension. So a surfactant will facilitate distension of the lung. Because it will decrease the surface tension. Surface tension is increasing the risk of collapse. So by increasing surfactant, it will decrease the surface tension, leading to more facilitation for expansion, for increasing the compliance. And it's inversely proportional to the wall stiffness. Why? Because if there is stiffness at the wall, there is no expansion. So there is decrease in compliance. So here there is increase in compliance, in which case lung easier to fill in obstructive conditions like emphysema, older adults, and the curve to the left. Why? Because the restrictive R to the right. So obstructive O in any shape, emphysema or any other shape into the left. Then decrease compliance. Lung more difficult to fill. There is decrease in distension, decrease in compliance. Why? Because there is fibrosis, there is restrictive pattern, restrictive R to the right. There is decreased compliance in pulmonary fibrosis, pneumonia, ARDS, acute respiratory distress syndrome, and pulmonary edema. There is decrease in compliance.